Assalamualaikum dan selamat petang semua. Hari ini saya akan teruskan dengan chapter yang pertama, iaitu Introduction to Digital Design. Untuk Introduction to Digital Design ni kita akan tengok pengenalan kepada apa itu digital design lah. Before that, you need to know the philosophy of digital design, platform and tools for digital design, and also programmable logic in digital design. Example for digital programmable logic such as programmable array logic, complex programmable logic device, and field programmable gate array, FPGA. For logic design, there are language that you need to know. Language to understand logic design. Logic design can be represented in Boolean, algebra, logic minimization, state, timing, or CAD tools. Concept of state in digital design is analog to variable and program counter in software system. So state usually in to logic 0 and logic 1. And then to design, to simulate our design, we use hardware description language software. This is software that we use to simulate our design. Other than that, logic compiler to synthesize the hardware block of our design. To convert language into machine language, programmable hardware that understand by machine. Other than that, for software design, maybe there need to be flawless, no error lah for software design compared to physical device. For application of logic design, there are several example of application. The first one is conventional computer design. Use logic design application. For example, in CPU buses, peripherals. Other than that, in networking and communication system, for phone, modem, routers. And also in embedded product. For example, cars, toys, entertainment device, and also scientific equipment for testing, sensing, and reporting. Before that, we also need to know the quick history, how digital design start. First, George Boole invents Boolean algebra. So this Boolean algebra it can represent logic design. So by using Boolean algebra, we can manipulate logic statement. Based on mathematical operation. And then Cloud Shannon links Boolean algebra to switch. This is starting for logic design using switch. Okay, and then John von Neumann developed first program computer. Okay, John von Neumann developed computer based on vacuum tubes. Okay, and then ENIAC, world first all electronic computer that use 18,000 vacuum tube. In 1947, Shockley, Britton, and Bardeen invent transistor. This transistor replaced vacuum tube, so system become smaller. Okay, computer become smaller. Transistor enable integration of multiple device into one package. Okay, one small chip. Okay, this is a gateway to modern electronic. Okay, what is logic design? Okay, what before that you need to know and understand what is design. Okay, design is we have a specification of problem, and then we come up with a way to solve the problem. Okay, by using or by choosing a collection of available component. Okay, this we need to meet some requirement. Okay, for example, criteria, size, cost, power, beauty, elegance, and others. Then we need to understand, we need to know to what is logic design. Okay, logic design is determining determining the collection of digital logic components to perform or specified control and data manipulation. Okay, so this one we communicate, connect it, interconnection between logic component. Then which logic component to choose depend. Okay, there are many implementation technology. Okay, programmable, transistor on chip, and then the design may need to be optimized or transformed to meet design constraint. Okay, what is digital hardware? Okay, digital hardware control wires or device that carrying a digital value. Usually we use 0 and 1 value, binary number. Okay, for example, voltage 0.8 is voltage 0. Okay, is for 0 logic, 0 number, and then voltage 2.0 for logic 1. Okay, this example for digital logic, digital value. Okay, for the logic computation device, for example, we have two input, two sense, and then go into one central system, then output, get output from the system. Okay, what is happening now in digital design? Now design become larger and larger, but we have shorter time to market the design. Okay, and then cheaper product. So this trend nowadays, we need to uh, make a cheaper product, and then for scale we have uh, excessive use of computer aided design. Okay, to tools uh, to design, and then we have multiple level of design representation. For type, we have we have to emphasize on abstract design representation. Then we use programmable rather than fixed function component. And then for the cost, use simulation to debug design. Okay, so this will reduce cost. Then for programmable logic, compared to microcontroller in prototyping, okay, we have programmable, or we can, for programmable logic, it's more general and flexible, economic for mass production. Whereas for a microcontroller, it's more for specific function and less flexible, but it costs more in mass production. Okay, for this digital design is programmable logic. Microcontroller you will learn in microcontroller and microprocessor. Okay, basic unit of computation. We have 0 and 1, because 0 and 1 is for binary. And then assignment, x equal to y. For data operation, x plus y minus 5, this example of data operation. And then for control, we have sequential statement. Okay, we execute statement A, statement B, and statement C. This in follow in order. And then for conditional, you can jump from one statement to another statement based on condition. And loops, the program will execute execute such a statement in loop until meet the meet, meet the limit. Okay, meet the specification. Okay, for procedure is same as statement, sequential statement. We execute one by one. Okay, this basic element of physical implementation. Okay, for switches, we have to relate to binary 0 and binary 1. Okay, for example, if we press or we close switch A, consider as 1, and then the light will turn on, light bulb will turn on, so it's considered as 1. Z equal to A. If A is open, it's considered as 0, and then Z will turn off, light bulb will turn off, then it becomes 0. So Z equal to A. And then in terms of more complex function, A and B, we have to switch. If A is 0, B is 0, then we close A and B, so the circuit will complete. And then maybe if we connected to light or bulb, it will turn on. Okay, that's why for serial connection. And if we use parallel connection or parallel circuit, is considered as O. Okay, for serial is considered as N. So if either one switch of the switch we close, and then the circuit will complete either one. But if you open both switches, and then the circuit will not complete. Okay, for switch setting, determine whether or not a conducting path exists to light the light bulb. Okay, we build a larger computation. We use a light bulb to set other switches input to another network. So this more complex circuit, and then we connect together a switching network. Okay, one output of the one network to the input of the next, so it become larger switching network. Okay, this example of another switch, relay network. So this relay network use concept electromechanical relays, electromechanical concept. So combination of electrical and mechanical. So if we close the switch, and then the current flowing through coil, magnetized core, and cause normally close contact to be pulled open. So it become as switch. When no current flow, the spring of the contact returns to its normal position. Actually, relay also act as a switch, but relay are not used much anymore nowadays. Modern digital design are designed in CMOS technology. We use CMOS technology. CMOS stands for metal oxides on semiconductor. Okay, C is for complementary because they are both normally open and normally closed switch. Okay, this one I think you have learned in electronic principle. Okay, most transistors act as voltage control switch. Okay, similar but is easier to work with than relays. Okay, this concept of MOS transistor, there are three terminal: drain, gate, and source. If voltage on gate terminal is higher than or lower than source terminal, then a conducting path is established between drain and source terminal. This is for N channel, and this is for P channel. Okay, this example of MOS network. So you can complete this table. Okay. If we we give x 0 volt, and then what is the output? So you need to complete the table. And then this another example for two input network. Okay, x, y, z. Okay, mapping from physical world to binary world. Okay, there are many ways or many technology to represent 0 and 1. Okay, for binary, relay logic, circuit open for state 0, circuit closed for state 1. And then for CMOS logic, 0 to 1.0 volt, 2.0 to until 3.0 for state 1. Okay, then another example is fiber optic. If we turn off the light, and then it's indicate as state 0, and then we turn on light, is indicate as state 1. Okay, there are many technology. Okay, magnetic disk, compact disk. Okay, programmable ROM. Okay, we continue with conventional and sequential digital circuit. Simple model of a digital design is a unit with input and output. We have input go into the system, and we have output. Okay, conventional mean memoryless. Okay, it mean input direct to the system and get output, and that's it. So this for conventional circuit, digital circuit. The output value only depend on its input value. Okay, for example, we have buffer, not and or not or. So we have input, and then we have output. Okay, for sequential logic, sequential digital logic system, the output depend not only on the current input value but also on previous input values. Okay, so it will consider the previous input value. Then the output is not permanent, is not same as previous output. This is very from previous output. So we need to look at output only after sufficient time for the system to make its required change and settle down. Okay, we need to wait for sufficient time. Okay, output of conventional circuit depend only on current input. Okay, after sufficient time has elapsed. But for sequential circuit have memory even after waiting for the transient activity to finish. So it depend on the previous input or previous output. So this is memory. If we consider previous output, so it's a memory system. But for the conventional logic circuit is memoryless, only depend on its input values. Okay, it's depend, for conventional is depend on not only for current input but for the previous input, okay, the output. Okay, change in the system state are only allowed to occur at specific time controlled by an external periodic clock. Clock period is the time that elapses between state change must be sufficient long so that the system reach a steady state before the next state change at the end of the period. Okay, so we need to wait before the system becomes stable. Okay, this example of conventional logic. So this we have input go into the system based on clock timing. Okay, timing based on clock, and then we have output. Observe, see again, we stay the same. Okay, and then for sequential, okay, this example, we have to input, wait for clock edge, and then observe C. Wait for observe C again, it may be different. Okay, because it's based on previous input. So it will maybe it's vary or is